Welcome to this explainer. Let's kick things off right away by diving into a massive, frankly terrifying problem in the enterprise tech world right now. Why throwing basic AI at your complex corporate data almost always leads to highly confident, but financially disastrous answers. Look, we've all seen those incredible, dazzling demos, right? You watch an AI seamlessly answer questions about a basic company HR policy, or maybe it summarizes a generic support article flawlessly. It literally looks like magic. But here's the reality check. When enterprise teams take those exact same AI models and point them at their deep, complex, historical business data, like a massive 12-year-old ERP system, the results are absolutely chaotic. I want you to imagine an AI looking your CFO right in the eye and confidently stating that revenue is up 20% this quarter. Why? Simply because it happened to read an overly optimistic draft email from a sales rep, completely ignoring the final, mathematically reconciled ledger. It happens all the time. So today we're going to completely unpack exactly why these alarming disconnects happen, and more importantly, how modern cognitive architectures actually solve the problem.
Okay, let's look at the hard numbers, because despite massive, billions of dollars level advancements in the underlying tech, standard models still hallucinate 28.6% of the time. And that failure rate is leading 47% of enterprise users to make poor, sometimes catastrophic business decisions based on fabricated data. That is a staggering, deeply concerning statistic from recent industry benchmarks. Think about it. If you're just a consumer asking a chatbot for a fun pancake recipe and it hallucinates an extra egg, well, whatever, it's a minor annoyance. But for enterprises, the stakes are entirely existential. You literally require strict factual accuracy, absolute regulatory compliance, and a verifiable, traceable audit trail for every single metric you report. Deploying a raw large language model against proprietary business data isn't just a slightly poor strategic choice, it is a massive ticking corporate liability. If an AI generates a fabricated compliance report for you, you aren't just dealing with a quirky software glitch, you are potentially facing severe regulatory fines, intense legal exposure, and a total, unrecoverable breakdown of stakeholder trust.
So this raises a massive, absolutely crucial question. Why does an AI that has literally read your entire corporate library fail so spectacularly at basic quarterly reporting? It's all about the fundamental gap between reading unstructured text and actually understanding structured business context. You can feed a model every PDF, every single email, and every memo your company has ever produced since its inception. It will read them and it will summarize them perfectly. But the second you ask it to tell you what changed in accounts receivable compared to the previous period, it suddenly struggles, panics, and just starts making things up. Why? Because an AI reading plain text is fundamentally, structurally different from an AI navigating relational databases and implicit business rules. For example, let's say the unstructured text in an executive's email says, "Boom, we successfully closed the Acme deal." The model reads that and thinks, "Great, more money." But the implicit business rule buried in your database knows that a deal isn't recognized as actual revenue until the contract is signed, the invoice is generated, and specific payment terms are met. The model, simply speed reading the text of that email, misses that operational reality entirely.
To understand how to fix this, we'll follow this agenda. First, the AI promise and risk. Second, the vector RAG illusion. Third, structured data failure. Fourth, graph and semantic solutions. Fifth, a performance comparison. And finally, building the semantic nervous system.
Let's jump right into Section 1, the AI promise and risk, and how we actually go about grounding AI in reality. When organizations initially tried to solve these massive AI hallucinations by grounding models in their own private data, they realized very quickly that fine-tuning was a nightmare. Fine-tuning, which literally means training your knowledge directly into the neural weights of the model itself, was incredibly expensive, and it created a rigid, static system. Think about it. If a critical tax regulation changes tomorrow morning, a fine-tuned model doesn't know anything about it unless you spend weeks and hundreds of thousands of dollars retraining it from scratch. There's no way. That's exactly why retrieval-augmented generation, or RAG, was hailed as the absolute savior of enterprise AI. RAG drastically reduces hallucinations by pulling in verified documents before the AI even attempts to answer. At a high level, a vector database turns your words and sentences into numerical values, plotting them in a vast, high-dimensional space based on their core semantic meaning. When a user asks a question, the system searches that secure internal database for relevant info, grabs it, and essentially tells the AI, "Hey, answer the user's question, but only use this provided text." This is brilliant because it keeps your data private, avoids retraining entirely, and gives you a clear audit trail. But, as we are about to explore, this specific method has a massive, highly dangerous blind spot.
Moving on to Section 2, the vector-RAG illusion, and the danger of treating all data as text.
Here is the critical blind spot that is actively tripping up so many smart enterprises right now: the incredibly dangerous attempt to force complex, tabular ERP data into flat text just so they can use semantic vector search. Look, a standard operating procedure or a legal brief, that is naturally unstructured text. Vector search loves that. But an enterprise database is highly, rigorously structured. It relies on explicit relationships, foreign keys, and highly specific column definitions. When engineering teams try to use the exact same retrieval pattern for a basic support article as they do for their core transactional database, they fall into what we call the naive workflow. They literally export their beautifully structured database rows or their massive financial reports into flat text files. They chop them up into little chunks and turn them into numerical vectors. Then, they ask the AI to just magically infer an answer based on semantic similarity. It's ridiculous. Think of it like taking a fully built, intricately designed Lego castle that perfectly represents your entire database architecture. Now smash that castle into thousands of individual, disconnected bricks. Toss them in a pile, and then ask the AI to perfectly guess what the entire castle looked like just based on the color of 5 random bricks it pulled out. You have completely, entirely destroyed the inherent structure.
Let's see this disaster play out in Section 3, Structured Data Failure and the Problem of Missing the Joins. Let's look at what actually happens when we ask a real, operational business question using this basic, naive vector pipeline. Here's the thing. Enterprise users don't ask questions using database schema names. They speak in human, everyday business language. A VP of Finance doesn't walk into a room and say, select from table X where column Y equals Z. They just ask normal questions. This language gap combined with the total loss of those structured relationships we just talked about creates a perfect storm for absolute failure. Let's say a user simply asks, which customers had delayed payments last quarter? The system immediately panics and desperately tries to find semantically similar text chunks across thousands of exported, flattened tables. But consider the incredible hidden complexity here. In a real enterprise system, answering this one seemingly simple question requires checking the invoice due date in one table, cross-referencing the actual payment posting date in a completely different table, checking an allocation status in a third table, and then finally verifying the customer's specific, highly customized credit terms in a fourth table. It's an intricate, multi-layered web of data that simply cannot be flattened.
So what does the system do with that complex query? It fails. It pulls up some text chunks describing generic invoice status, but it completely misses the complex payment allocation rules stored in that separate fourth table. The result? You get an AI answer that looks incredibly confident, is beautifully formatted with bullet points, and yet is financially wrong by 18%. I mean, being 18% off on your financials, that's not a glitch, that's a resume-generating event. This isn't just a theoretical academic issue. This is a catastrophic real-world scenario that happens every single day when teams misapply this technology. Vector search simply is not designed to discover relational execution plans. It grabs whatever text mathematically looks most similar to the words delayed and payments. The language model doesn't have the capacity to stop, hold up its hands and say, wait a minute, I am clearly missing the critical join path to the payment rules table. It just confidently hallucinates an answer based on the partial, fragmented context it happened to retrieve. It guesses an aggregation instead of actually computing it. Relying on this for your company's bottom line is a guaranteed recipe for disastrous business decisions.
So how do we fix it? That brings us to Section 4, Graph and Semantic Solutions, where we actually map the business. This is where we introduce the competing, highly advanced approach, using knowledge graphs and context APIs to actually preserve your deep business meaning and your complex relationships. Instead of dumping everything into a flat text file and just hoping that semantic similarity will magically reverse engineer your ERP's architecture, we need a method that respects and actively maps the actual business logic. Enter GraphRAG. What's really fascinating here is that GraphRAG doesn't just read isolated chunks of text, it actively maps out the exact relationships. It understands how a specific data column relates to an upstream source, how that relates to a company policy, and who the ultimate data owner is. In a knowledge graph, your data isn't just a dumb text chunk, it's an entity, and it's connected to other entities through specific, explicitly defined relationships. This enables something incredibly powerful called multi-hop reasoning, which perfectly mimics human deductive logic. If you ask about a delayed payment now, the graph inherently knows that the invoice entity is explicitly, permanently connected to the customer entity,
which is in turn directly connected to the credit terms entity. It securely traverses these exact connections, hopping from node to node, building a complete, structurally sound, mathematically accurate picture before it ever hands the context over to the AI to summarize.
Let's put these two head-to-head in Section 5, Performance Comparison, Vector versus Graph.
All right, let's directly compare these two retrieval methods head-to-head across different types of enterprise tasks, because the reality is you absolutely need both. The goal here isn't to declare one universally superior to the other, but to intelligently route the right query to the right architectural pattern. We have to clearly define this dichotomy. On side one, naive VectorRAG is the undisputed champion of unstructured data. It is fantastic. It's incredibly fast, super cheap to implement, and perfect for things like employee handbooks, standard operating procedures, and basic HR policy lookups. Why does it work so well there? Because in unstructured documents, the semantic meaning is already embedded directly in the sentences themselves. A text chunk captures the full thought. However, as we established, exporting complex tables to text chunks guarantees failure. So on side two, we have GraphRAG. Now, it does introduce a bit more latency, and it absolutely requires a higher initial investment to build out those complex entity relationships. But it absolutely dominates when it comes to business context, ledgers, enterprise resource planning, and supply chains. Why? Because in structured data, the core meaning isn't embedded in sentences, it's embedded in the relationships. It's the literal lines drawn between the nodes. GraphRAG achieves an astonishing 90 to 97% precision by successfully navigating that exact structured business context, mapping out the true connections that define how your business actually functions on a daily basis.
Looking closely at the data on this table, we clearly see that for true operational aggregations and hard financial calculations, schema-aware retrieval using a knowledge graph entirely outclasses basic vector search. Throwing VectorRAG at an aggregation task is mathematically doomed from the very start. Let's drill down into exception detection just to illustrate this vividly. If you ask a basic vector RAG system, hey, which invoices look abnormal this month, it literally just searches for and retrieves invoices that happen to contain text similar to the word abnormal or exception. Maybe someone typed exceptionally good in the notes. That is absolutely not anomaly detection, that is just a basic, glorified keyword search function. A graph for semantic capability, however, is purpose-built for this exact workflow. It actually understands the broader, nuanced business concept of an exception. It can dynamically look at computed baselines, it checks specific financial thresholds, and it runs historical comparisons that are defined structurally in your schema. This ensures you get real, actionable operational intelligence rather than just dangerous, context-blind keyword matching. Finally, let's tie it all together in Section 6, Building the Semantic Nervous System. To actually implement this successfully in the real world, we need to stop looking at AI as just some cool software add-on and start treating enterprise architecture like a living, breathing biological organism. Think about it. For decades, companies have built massive data lakes and massive data warehouses, essentially creating completely disconnected organs of data. Marketing has their massive bloated organ of data over here, while finance has theirs completely siloed and locked down over there. If your data lakes and warehouses are isolated organs, taking a phenomenally powerful AI brain and just plopping it on top doesn't solve anything. It just scales the confusion at an unprecedented rate. A human body might have incredible healthy organs and incredibly strong muscles, but without a central nervous system to connect perception, timing, and coordination, it absolutely cannot function intelligently. The exact same is true for your company. You urgently need a semantic nervous system. You need a connective layer that sits across the entire enterprise landscape, creating a unified, intelligent interface that actively translates raw, distributed, siloed data into coherent, synchronized business meaning that an AI can actually understand and, more importantly, trust. So how do we build it? This step-by-step evolution is your exact blueprint for creating a true cognitive architecture. Step 1, you have to explicitly map your human business concepts to your actual physical database schema. This way, the AI inherently knows that the phrase order date means the exact posting date for the finance team, but it means something entirely different for the logistics team who is shipping the box. Step 2, you embed this structured context using open standards like the Model Context Protocol, or MCP. Think of MCP as a standardized, open-source way to hand the AI a complete, perfectly drawn, highly detailed map of your database before it even attempts to answer a question. It delivers curated, semantically enriched metadata directly to your AI agents in real time. Step 3, you dynamically route queries based on the task type. Like we talked about, simple text lookups about the HR handbook go straight to your fast vector RAG, while complex multi-hop financial calculations go immediately to your semantic graph layer. And finally, step 4, you build hard guardrails. You automatically validate the AI's mathematical answers against hard-coded business rules before a human being ever even sees the response.
I absolutely love this insight because it perfectly captures that merely moving data around from server to server just isn't enough anymore. We have to actively, intentionally synchronize its meaning across the entire business landscape to achieve true intelligence. We have to move away from just extracting and loading data to actually preserving the actual structural reality of the data. When your corporate governance, your ethics, your hard business rules, and your strategic priorities are actively mapped and embedded directly into this semantic nervous system, AI stops being a massive, terrifying hallucination risk. Instead, it transforms. It starts being a true, reliable accelerator of enterprise wisdom. It becomes entirely capable of logically reasoning through your most complex operational and financial challenges, parsing structured context versus unstructured text without breaking a sweat.
And that leaves us with this final, incredibly vital thought for you to chew on. To achieve real decision intelligence, your AI must be grounded in an architecture that preserves the truth, not just the text. I want you to take a hard, honest look at your current AI deployments right now. Are you treating your highly complex, intricately relational financial and operational data like a simple, unstructured text document? Or are you investing the time and resources into building a robust cognitive architecture, a true knowledge graph that actually understands the intricate relationships that make your business tick? Because the difference between those two approaches is the exact difference between an expensive, hallucinating parlor trick and a true, scalable, massive competitive advantage. Thank you so much for joining me to unpack all of this today. Keep questioning how your data really works, and I'll see you next time.